Hey there. What if you could shrink a whole pizza into one decision? Eat it or don't eat it. That's exactly what a tiny piece of a neural network does every day. It takes a bunch of clues, like how hungry you are or if the pizza is still hot, and squishes them down into a simple yes or no. Today, we're going to build that tiny brain cell together, no coding required, just easy math you can see. When scientists first tried to teach machines to make decisions, they needed something super simple to start with, like a single Lego brick before building a whole castle. That brick is called a perceptron. It's the smallest piece of a neural network that can learn from examples, just like you learn from mistakes when you're trying something new. Imagine you're at a traffic light. What clues tell you to stop? The color red is a big one. Green means go. A perceptron does the same thing with numbers. It looks at clues, weighs how important each one is, and then makes a yes or no decision. Each clue is called an input. In our traffic light example, the input for red is 1 because red is very important for stopping. Green is 0 because it doesn't help you stop at all. The perceptron also has tiny numbers called weights that tell it how important each clue is. Let's pretend the red light weight is 2.0, green is 0.5, and yellow is 1.5. The perceptron multiplies each input by its weight and adds them together. For a red light, that's open parenthesis 1 times 2.0 close parenthesis plus open parenthesis 0 times 0.5 close parenthesis plus open parenthesis 0 times 1.5 close parenthesis is equal to 2.0. It then compares that to a threshold, let's say 1.5. If the sum is bigger than 1.5, it says stop. But what if the light is yellow? The sum is open parenthesis 0.5 times 2.0 close parenthesis plus open parenthesis 0 times 0.5 close parenthesis plus open parenthesis 0.5 times 1.5 close parenthesis is equal to 1.0 plus 0 plus 0.75 is equal to 1.75. That's still bigger than 1.5, so the perceptron says stop. But we know yellow usually means slow down, not stop. That's where learning comes in. When the perceptron gets it wrong, it adjusts its weights slightly to do better next time. If yellow should have been a go decision, but the perceptron said stop, it makes the green weight a tiny bit bigger and the red weight a tiny bit smaller. That's learning. Let's try another example. Suppose you're deciding if you should bring an umbrella. The clues might be cloudy and rain forecast. Cloudy is 1 if it's cloudy, 0 if not. Rain forecast is 1 if rain is likely, 0 if not. The weights might be cloudy equals 1.2 and rain equals 2.5. If it's cloudy but no rain, the sum is open parenthesis 1 times 1.2 close parenthesis plus open parenthesis 0 times 2.5 close parenthesis is equal to 1.2. The threshold is 1.0, so the perceptron says bring an umbrella. That makes sense. If it's rainy but not cloudy, the sum is open parenthesis 0 times 1.2 close parenthesis plus open parenthesis 1 times 2.5 close parenthesis is equal to 2.5. That's way above 1.0, so the perceptron also says bring an umbrella. Perfect. What if it's partly cloudy and a little rain is forecast? The sum is open parenthesis 0.5 times 1.2 close parenthesis plus open parenthesis 0.5 times 2.5 close parenthesis is equal to 0.6 plus 1.25 is equal to 1.85. Still above 1.0, so bring the umbrella. Smart. Now, what if it's clear skies and no rain? The sum is open parenthesis 0 times 1.2 close parenthesis plus open parenthesis 0 times 2.5 close parenthesis is equal to 0. That's way below 1.0, so no umbrella. Perfect. So far, we've used made-up weights. But how does a perceptron learn the right weights on its own? It starts with random weights, like cloudy equals 0.1 and rain equals 0.3, and then adjusts them every time it makes a mistake. The adjustment is tiny, just a little nudge. Let's say the perceptron sees a cloudy day and says no umbrella because the sum was too low. But you know you need an umbrella. The perceptron adds a tiny bit to the cloudy weight and the rain weight. Maybe cloudy becomes 0.3 and rain becomes 0.5. Next time it sees a cloudy day, the sum will be a bit higher, so it's more likely to say umbrella. That's how learning works. tiny nudges over and over until it gets it right most of the time. This tiny process is the heart of how all neural networks learn. A perceptron looks at clues, weighs them, and makes a yes/no call. When it's wrong, it adjusts the weights just a little. Over time, it gets smarter, just like you do when you practice something new. But here's the catch. A single perceptron can only solve very simple problems. It can't tell the difference between a dog and a cat, or recognize a face, or understand a sentence. It's like a single Lego brick. Useful on its own, but to build something big, you need lots of them working together. That's why in the next video, we're going to stack perceptrons on top of each other to build a real neural network. Each perceptron is like a tiny assistant that looks at part of the problem, and together they solve something much bigger. That's it for today. If you want to see how perceptrons team up to solve bigger problems, hit subscribe so you don't miss the next video. See you then.